Since the beginning of aerial reconnaissance in the 18th and 19th centuries, there was a need to interpret what was being recorded by those overhead platforms. Eventually, during the two world wars, this developed into a discipline known as IMINT, or Imagery Intelligence. And in this episode, we'll see how artificial intelligence is helping IMINT analysts with objects recognition and classification in today's era. Welcome to Tradecraft Sunday. During the early days of IMINT, whether that was imagery from spy planes or satellites, highly skilled IMINT analysts had to spend hours upon hours studying each frame and documenting what they see. This is an aircraft of that type, this is a tank of that type, that military base has that many unarmored vehicles parked, those are roads, and so on. Even in the United States Central Intelligence Agency's museum, you'll see this artifact being displayed, indicating the importance of the IMINT analysis. This stereoscope was used during World War II to help photo interpreters by viewing the film in 3D. Of course, technology has evolved over time, and from that level of manual IMINT, we have moved to more modern methodologies. For instance, even in the commercial world, there are nowadays solutions offering automated recognitions of objects from overhead imagery. In this example, you see a product offered by a very popular private intelligence firm named James. This can make an IMINT analyst's life easier, reduce human biases and errors, and boost the velocity of the intelligence cycle, but there is more to it. The last few years, an AI domain known as machine learning or ML has revolutionized this once more. In summary, ML scientists are taking vast amounts of data related to a specific asset. For instance, here are millions of satellite images of airfields and then develop an ML algorithm which is trained as per ML terminology using that dataset and is then able to recognize similar patterns against new images that are being thrown at it. This can be done with any object. That could be tanks, military bases, bunkers, radars, ports, ships, and so on. And the better the algorithm and training data, the higher accuracy the recognition results are going to be. Here's, for instance, a commercial service offered by a private firm called Crowd AI. Many more companies offer similar capabilities, and of course, there are several similar solutions developed by spy agencies that are still classified which are using such technologies. And there are some commercial ones which are only available to spy agencies, like for example Maxar's Deep Core Suite, which as we read, is an end-to-end artificial intelligence and machine learning pipeline for self-service computer vision analytics. The Deep Core system is key in mapping and analytic workflows, reducing time to mission and allowing analysts to focus on the why rather than data collection and validation. Or L3Harris, which in 2020 announced that L3Harris is building a new platform that will help analysts in the military use artificial intelligence to identify objects in large imagery datasets. In general, there is a big challenge with the amount of remote sensing data that's coming down, whether that's from space or airborne assets, explained Will Rohrer, Principal of Business Development for Geospatial at L3Harris Technologies. So there is lots of imagery and other data types coming down from above, so much that it really can't be looked at its entirety certainly not exploited in its entirety by traditional means with purely human analysts. And so things like counting objects in imagery, monitoring different places, that's where there is a natural adoption of machine learning type of techniques, he continued. Even Vice Admiral Robert Sharp, director of the US National Geospatial Intelligence Agency, the NGA, stated in April of 2022 that this move brings together two major Department of Defense AI and ML efforts under one roof, he said, adding that the agency saw this opportunity to provide strategic leadership and a corporate approach to GeoINT AI investments. In the coming months, NGA will be calling on the industry to collaborate, move forward together so we can deliver GeoINT at the pace that our warfighters and decision makers need. We have to be able to keep up with the rapidly emerging digital trends. We have to be able to accelerate our ability to provide detections at the speed of mission, to give our customers tactical, operational, and strategic advantage, he said. Unsurprisingly, nation-states are also developing countermeasures to make those automated intelligence analysis systems less effective. For example, from World War II we have been seeing inflatable assets, and those are used even to this day to confuse IMINT analysts. We have traditional camouflage, sometimes also referred to as masking, which tries to mimic the environment, and depending on the technology used, it can make it harder to hide from EO sensors. Hiding is another option. Caves, underground facilities, tunnels, and various other options that all nation-states use globally. A lesser-known technique is that of repackaging, where a certain type of asset is covered so that it can confuse automated IMINT to classify it as something benign. Another means recently observed on several Russian Navy vessels is repainting them the way you see here in order to make their signature look different from overhead imagery. It has not been officially confirmed that the objective was to confuse those ML automated recognition solutions, but it's a very plausible scenario. Although machine learning can significantly improve the IMINT analysis for object recognition, only an experienced IMINT analyst can uncover those and other countermeasure techniques and procedures that nation-states utilize today. Apparently, object recognition using AI isn't the only use of those new technologies in the spy world, but it's a great example of how IMINT analysis has evolved over the decades and a little-known modern tradecraft of the GeoINT world.